This video is to help with the learning target. I can solve mixture word problems that are modeled by the fact volume of the mixture times concentration of a substance equals the amount of the substance in the mixture. This fact can be thought of as y equals m times x. We use the same type of fact, which we would call a linear model, when we talk about distance equals rate times time. So the strategies that you learn in this video, you can use also with those types of problems. Let's take, for example, a 27 milliliter mixture of water and orange juice. This mixture is said to be 32% orange juice. What is the amount of milliliters of orange juice in this mixture? Now, a percentage is per 100. And we're not looking for a percentage, we're looking for the volume of orange juice. In order to find this volume of orange juice, we would take the volume of the mixture, and this was the water in the orange juice, times the concentration of the orange juice to tell us the exact volume of orange juice in that mixture. So from the 27 milliliters, 8.64 milliliters is orange juice. This is an example of the fact that we use with types of mixture problems. Let's take an example where we have 151 liters of a mixture. 72% of that is fruit juice. This fruit juice, though, is too strong, and it needs to be diluted with water. The question: how much water needs to be added to change the mixture to one with a 40% concentration of fruit juice? Pause the video if you need to take some time to read the problem again. And if you have some strategies in mind, give them a try. And then hit play. In this video, I'm going to model for you how to use the information that's given in the problem, the fact that the mixture volume times concentration equals the substance volume, and a table. There may be other strategies to solving these problems. I'm going to start with the table here because I think it's a good graphic organizer to take a word problem and try to find the important information and set it up in a way to help lead to a solution. You'll notice in the table that we have mixture volume times concentration will equal substance volume. Our original mixture had 151 milliliters with a 72% concentration. If we multiply across on our table, this gives us the milliliters of actual fruit juice in the mixture. We're going to add water to this mixture, and water has no concentration of fruit juice. So when we multiply across, we're going to have a 0 in this cell right here. Finally, when using the table as a structure of organizing the information, the first column we would add down to get the final volume of the final mixture. We will multiply across again in order to get the final volume of the substance. Once we have our cells filled, it is this last column that we're going to use to set up the equation. And if we take the substance in the original mixture, add to it what we added to the original mixture, which in this case in concentration of the substance is 0, that will equal the concentration in the final mixture. We have our equation. X is our unknown. So we're going to go ahead and solve for x. Be careful here with your distribution process. Isolating the x, we find that x equals 120.8. We will need to add 120.8 liters of water to dilute the concentration of juice in the mixture. Let's take that same mixture of 151 liters of 72% fruit juice and increase the concentration to 85%. But this time we're going to use pure fruit juice. Pause this video if you'd like to give this one a try, and then go ahead and play to check your work with the solution work. Once again, we're going to use a table to take the information and organize it, and we're going to use that fact that the mixture volume times the concentration will equal substance volume. So the original had 151 milliliters, 72% concentration. Once again, we have 108.72 milliliters of fruit juice in the original mixture. But notice now, this time, because we're going to add a pure substance, I use a concentration of 100%, which is 1. And that gives me a 1x in this cell. We will add down in order to fill our last cell here. We will multiply across in order to complete the bottom right cell. And then we're going to use that last column to help set up an equation. We set up our equation. This time we notice we have an x on both sides of the equal sign. Care when we're distributing, solving for x. And we're going to find that we need 130.87 liters. We want to be certain to write our answers using sentences and a general conclusion. Please do practice writing the answers to the questions in complete sentences. Final conclusions. Let's take another scenario, and this time that we need to dilute the mixture again, but this time from 72 to 48. And we don't have any water, but what we do have is a second mixture with a 37% concentration of fruit juice. You can see here how the chart is complete. Once again, we're going to use that last column in order to set up our equation. Notice again that we do have x on both sides because we did not use water. And this time we're using a 37% additive solution. And we find that x equals 329.45 liters. Please do remember that you need to answer the question using sentences. 329.45 liters of the 37% mixture to the 72% mixture to create the new 48% fruit juice mixture. Hope this was helpful. Please bring your questions to class and add this to your notes. Thank you and have a good evening.